Hello everyone, welcome back to our channel. In today's session, we are going to cover uses of concave mirror, uses of convex mirror, and then mirror formula, magnification formula. The last but not least, we are going to see the sign convention using the mirrors, as well as we are going to follow the last one is refraction of light. Okay, now let's jump into the topic. Now, the uses of concave mirror. Before knowing the uses of concave mirror, we should know something. What is the image or what is the nature of the image formed by a concave mirror? It will be always real and inverted except the last one. When the position of the object is placed between pole and the focus, the position of the image will be behind the mirror. So the size of the image will be enlarged. So we can directly say that here the nature of the image will be virtually erect. Okay. This is the thing we want to know. Okay. Now, the uses of concave mirror. Where we are using the concave mirrors? We are using in the torchlights, searchlights, vehicle headlights, shaving mirrors, dentist mirror, solar furnaces. These are the places where we are using the concave mirror. Okay. Now we are going to the next topic, which is known as convex mirror. What is meant by convex mirror? We already know what is meant by a concave mirror. Concave mirror is the mirror which is curved inwards is known as concave mirror. When we go for convex mirror, the mirror which is curved outwards is known as convex mirror. Okay, here the example of a convex mirror. What are the examples or what are the uses of convex mirror? We are using it in the rear view mirrors in the vehicles. Okay, why? The main reason is it gives a wider field of view. Okay, please remember this point because it is very important for the board examinations. Okay, now the nature of the image formed by a convex mirror is always virtual and erect. Okay, now it's time for the key points. What are the key points in this uses of concave and convex mirror? The first one is the nature of the image formed by a concave mirror is always real and inverted except one point. Okay. Now, when we go for convex mirror, the nature of the image formed by a convex mirror is always virtual and erect. Okay. Now we are moving to the next topic, which is known as sign convention. Don't get panic about the image. Okay. Please don't get panic after seeing the image. The image will looks like a difficult one, but the concepts are very easy and we can make it in the fingertips. Okay. Now, please listen here. The thing is, here the object is represented by the symbol U. It is always negative. It will be always kept at the left hand side of the mirror. When we go for V, V is always represented as the image distance. Here U means the distance between the mirror and the image is represented as U. When we go for V, the distance between the mirror and the image is known as view. Okay. Now, when we go for the object U, it is always placed at the left hand side. It is always negative. Okay. But when we are talking about the image can be placed at the upside or downside. Based on that, we can able to judge the sign. Okay. If the image formed upwards means it will be positive. If the image formed downwards means it will be negative. Now it's time for the key points. Okay. When we are going for the key point, you should remember the focal length of a concave mirror is always negative. The focal length of a convex mirror is always positive. The next key point is U is represented as object. V is represented as image. Okay. The next one is U is always negative. For example, I'm giving a sentence. The object distance is 10 centimeter and the image distance is 25 centimeter. How to write it? U is equal to 10 centimeter. No, we should not write like that. U is equal to minus 10 centimeter. When we go for image, we get it as V is equal to 25 centimeter. Okay. I think everyone can able to understand, right? The next one is the second one, which are given in the table of contents. Object placed. It is always placed with the left hand side of the mirror. It is represented by the symbol U. It is always negative. That's all. Okay. If the image formed by the mirror placed upwards means or formed upward means it is positive. If the image formed by a mirror formed downwards means it is negative. Okay. The next one we are going to see the mirror formula. Most important formula in this chapter, which is known as mirror formula. What is the mirror formula? For example, I have a mirror, but I don't know about the focal length of the mirror. How to find the focal length? By using mirror formula, we can able to find the focal length of a mirror. How to find the focal length? 1 by f is equal to 1 by v plus 1 by u. We already know something. U is object distance. V is image distance. U is always negative. V may be positive when the image form upwards. V may be negative when the image form downwards. Okay. It is based on the position of the image form. Okay. Now, F is the focal length. Okay. Now, we are going to the next one. The next one is called magnification of a spherical mirror. Here, we can write it as M is equal to height of the image divided by height of the object. Instead of writing like that, we can also write it as M is equal to minus V by U. Okay. Here there is a key point. You should remember. Okay. M is negative when the image is real. If M is positive, then the image is virtual. Okay. Now we are going to the refraction of light. Refraction. Refraction means bending of light is known as refraction of light. For example, please see here. This point is considered as medium 1 as well as this point is considered as medium 2. Now we are going to talk about medium. One is rarer medium, another one is the denser medium. I will give you some example for rarer medium as well as denser medium. When we go for rarer medium, I can able to say that air and vacuum are the example for rarer medium. When we go for denser medium, water, ruby, diamond, glass. These are the examples for denser medium. Here, please look at this diagram. I'm just going to draw two medium. One is medium 1, another one is medium 2. Let us consider the first medium as rarer medium and the second medium as denser medium. Please look at this picture. Here, I can able to say that this ray is called as incident ray. Okay. This blue line represents the normal. When a ray of light incident on a transparent layer, what will happen? There will be a bending of light takes place because we are going to talk about refraction of light. When we are going to talk about reflection of light, there will be a bouncing of light. Here we are talking about bending of light, refraction. Okay. So refraction means, what is refraction? In fraction, there will be a numerator as well as a denominator like that. Here, one medium divided by another medium. Okay. Here, this is the transparent layer. When an incident light falls on incident light or incident ray falls on the medium, what will happen? There will be a bending of light takes place. Okay. So, please keep it in your mind. There are two key points. When a ray of light enters the rarer medium and it bends towards the denser medium. Okay. So rarer to denser means it bends towards the normal. Rarer to denser means when the light travels from rarer medium to denser medium means it bends towards the normal. When the light travels from denser to rarer means it bends away from the normal. Okay. What are the key points? Rarer to denser means it bends towards the normal. Denser to rarer means it bends away from the normal. Okay. Now we are going to see the laws of refraction of light. Okay. Now incident ray, refracted ray, and the normal interface of two transparent media at the point of incident all lies in the same plane. Okay. Same as the laws of reflection of light. So please listen here. Instead of writing this, we can write something else like incident ray, the normal and the refracted ray lies on the same transparent media. Okay. What is the second point? The second point is commonly called as Snell's law of refraction. What is meant by Snell's law of refraction? Snell's law of refraction is nothing but sin I divided by sin R is equal to constant. Okay. What is meant by sin R? The sine of the angle of incidence is known as sin I. What is meant by sin R? The sine of the angle of refraction is known as sin R. So the ratio of the sin I divided by sin R is equal to constant. This is known as Snell's law of refraction. Okay. Now the next point is known as refractive index. Instead of writing n, we can also write a symbol called as mu. Okay. What is refractive index? Refractive index is nothing but we are going to measure the speed of the light in two mediums. Okay. How do we measure the speed of light? We already know the formula of speed of light in a vacuum. What's the value? C is equal to 3 into 10 power 8 meter per second. Okay. Now, here, listen here, n is equal to the velocity of the light in medium 1 divided by the velocity of light in medium 2. This is important formula as well as nm is equal to speed of the light in air divided by the speed of the light in medium. This is the most important formula you should remember. So we can write it as n is equal to c by v. Okay. Here c represents the speed of the light in air or vacuum. Okay. The speed of the light in medium represents by v. Okay. Again, I will say that this formula as well as this formula are more and more important. We can expect these questions in your board exams. Okay. The next topic is lens. What do you mean by lens? Lens is nothing but the combination of two mirrors are known as lens. Okay. Now, convex lens and concave lens. This diagram represents the convex lens and this diagram represents the concave lens. Okay. Again, I will say that the most important key points which we have seen today are, the first one is image formed by a concave mirror is always real and inverted. Okay. Image formed by a convex mirror is always virtual and erect. Okay. These are the key points which we have seen when we are seeing about the topic called uses of concave and convex mirror. Okay. The next point is mirror formula. What is mirror formula? 1 by f is equal to 1 by v plus 1 by u. Okay. Here f represents the focal length, v is the image distance, u is the object distance. Okay. We should know something. U is always negative, which is kept at the left hand side of the mirror. The last key point is the focal length of a concave mirror is always negative. The focal length of a convex mirror is always positive. Okay. I think you enjoyed everything. Please share this channel to your classmates and your friends. Don't forget to click the bell button and then subscribe my channel. Thank you. Bye bye. Keep going. Keep growing.